Okay, a very good afternoon, everyone. We are starting our week three of the Geotechnical Engineering 2. See the coursework which is taught by Professor D.N. Singh sir from IIT Bombay. My name is Sumit Kumar. I am PhD research scholar at IIT ISM Dhanbad. In this coursework, I am taking in this semester specifically. I am taking Geotechnical Engineering 2 for you, where I am discussing the different problems, concepts, and whatever your doubt, I will try to solve it out. So we are in the week three of this coursework. In the first 2 week, what we have read, I will give the quick recap of that things, and then we move forward with the new things and some instruction I want to add on before going ahead. That is, you have to stay in the meeting if any problem arises due to network issue or any problem I get disconnected, please be remain in the meeting. I will rejoin and move ahead. Okay. And one most important thing is like this PPT, this presentation file or the other presentation file which I have presented in the previous classes are also shared with you by the NPTEL team, which you can access through the Google Drive link, which will be shared with you. The video which is going on live in this class is recorded by me and it will be shared with you through the YouTube link. So you can go across those in the later time as well. I think so up to this every instruction is clear. And one most important thing that at the end of the every class I try to give some problems. So please be go through those problems so that you can get a better understanding of the topics that what we are covering. Okay, I think so. We can move ahead with our coursework. So starting in the week three, we are studying geotechnical engineering two. What we have read, I will give the quick recap in the 5 minutes. Then we move with the new content. Okay, so the geotechnical engineering two. This is the week three class, and over here we are going to study the different tests. In this class, we are going to study the deeper aspects of the tri-axial test, vein shear test, and the some aspect of direct shear test. So this is the most important class where we are going to see that what type of equipment we are using during the test and what are the different procedure which we are going to follow, how we reach the result, how which type of test is said to be a little quicker test as compared to the another test. So those aspects which we are going to cover. Before moving to those points, I will try to sum up things and give a quick recap of the things which we are covered in the previous class. Okay. So in the previous class, we have understand the shear strength of soil. That what do we mean by the shear strength? That is the ability of soil mass to resist the shear force and measure of the soil resistance to the deformation or failure when subjected to shear stress. We understood the definition that what do we mean by shear strength in real term, and we understand the two of the aspects, the parameter which primarily govern the shear strength, that is nothing but the cohesion and angle of interpretation. Over there, we come to know that the cohesion represents the shear strength of soil particle due to intermolecular forces, while when we talk about the angle of internal friction, it represents the resistance of soil particle to the sliding and more relevant in the cohesionless soil. So this point is very much clear. We have discussed earlier. We talked about the different type of test like the tri-axial test, direct shear test, and the vein shear test, which we are going to perform to reach at the specific outcome. We also talked about the importance, that what are the importance of the understanding of shear strength, why the shear strength is important, why we are keen to know that what is the shear strength and how we can achieve that. So those points we have covered, and the importance of shear strength is so much significant that if the shear strength of the soil is not known, we could not sustain that how much load the structure can withstand without any failure. Okay, so those points we have covered very clearly. When we talk about the shear strength in the granular soil, we talked about the sand that exhibit the unique behavior under stress. In flexible boundary containers, granular soil tend to flow when subjected to stress. In the rigid boundary container, the volumetric deformation occurs, leading to the changes in the shape and the density of the soil. Crushing, bending, rolling mechanism can also affect the shear strength of the granular soil. When we talk about the shear strength in the cohesive soil, over here, the clay requires special consideration in terms of shear strength, as the compaction characteristics are crucial in achieving the desired shear strength in the cohesive soil. Decreasing the permeability and the preventing the consolidation settlement are the key objective in the compacting cohesive strength. The development of the shear stresses and the slippage is the common in the cohesive soil under the excessive load. We also come across the knowledge about the excessive loading and shear failure. So those things we have discussed. I am giving the quick recap, so I will not go anything in detail. Just move slide by slide. We also understood about the shear strength, that is the fundamental concept in the geotechnical engineering, and it is a key factor in designing the foundation, slopes, retaining walls, and the different geotechnical structures. Whatever structures which we are going to make, the shear strength is one of the most important aspects. And the state of stress in the soil is characterized by the normal stress sigma and the shear stress tau. These stress are result of the external forces acting on the soil mass. The critically of the soil mass leads to the formation of the plains where the stress are concentrated. Each point with the soil mass experiences the critical stress simultaneously. Okay, up to here everything is clear, I think so. So we will move ahead. Give me a minute. Okay, so we will move ahead. And we will see that we understand about the parent body and the detached body. We understood about the critical shear stress, the amount of stress which acts at certain point. So after which the failure takes place, there is a too much heat over here. There is no electricity. There is a power failure over here. So that's why the condition are not as normal as previous classes. So little bit difficulty I am also facing during this class. So there is no backup due to power failure or the network issue if the class get disconnected at any point of time. So please we remain in the meeting. We will rejoin and move ahead. Okay. So I am talking about the detached body and the parent body we have discussed during the previous two classes in many times. So I am not over there. We talked about the triaxial state of stress. I am not concerned about talking about this over here because we will discuss this today and as well in the next class. We talk about the shear stress and normal stress, the interrelation which will provide the tau and sigma, that is the stress at the specific angle alpha at the specific plane which act at the alpha angle. We talked about the equilibrium used equation and the Mohr circle. When you talk about the Mohr circle, we see the maximum principal stress, minimum principal stress, and the shear axis and the normal axis, and how the value are obtained. During the first class, I have discussed about these things, and we talk about the property sign convention. We talk about the principal stress, that is the major principal stress and the minor principal stress. In this diagram, we understood that how the origin of the Mohr circle could be found and how we are able to know the value of the principal major stress and the principal minor stress. We also understood how the radius could be found, and the next over here you can see the interrelation between the sigma to get the sigma p1 and sigma p3 respectively. And so, sorry, okay, there is a network problem over here, I think so. Let me check. Hello. Okay. So in this manner, we are able to find the maximum principal shear stress and the minimum principal shear stress. We solve some problems, so I will not going through those problem over here. We talk about the generalized law and we solve some more problems. After that, we understood about the Mohr-Coulomb failure criteria. So we talked about the Mohr-Coulomb, Mohr circle. After that, we talked about the Mohr-Coulomb. We understood the relation between the sigma 1 and sigma 3 and how the Mohr circle is formed, how the Mohr-Coulomb failure envelope created as first of all stress is applied and like the confining stress is applied. We talked about this in the triaxial test setup as well. So the stress is applied and a circle get formed, then the sigma 3 gets changed, and the sigma 1 minus sigma 3, that is the deviating stress or the axial stress, is also get generated. And on the basis of that, we are able to form a tangent which is going through that Mohr circles. And the value of the angle which made with the horizontal axis of this tangent is the value angle called phi, and the intercept is the cohesion. And one most important point over here, that is the Mohr-Coulomb failure envelope represent the failure section. If any state of stress touches this envelope curve, the failure takes place at the same point of time. But if value remain below it, there is no failure takes place. Okay, so we understood those concepts. After that, we talk about the what are the different type of tests which we perform in the which we perform in the analysis to find the shear strength or the how much shear stress get acting. So different shear and different tests are the shear box test, that is nothing but the direct shear test. The second is the triaxial test, third is the vane shear test, fourth is the torr shear test, fifth is the flat jack test, and the sixth is the penetration test. But over here, the three is the primary test, that is the shear box test, triaxial test, and the vane shear test. We are going to discuss about these only in the broader aspects. But in a small one line definition, we will see all of them. So see the shear box test. Actually, the shear box test is a 2D simulation of the soil condition. It provides a plane strain or the plane stress representation of a shearing behavior. It is has the limitation in the replicating a real world 3D condition. In this, there is a when we talk about the triaxial test over here, the 3D application of the stress material is represented. It offers a better replication of in situ stress condition, help in understanding the soil behavior under the more complex loading. So actually, it represents the replica of the real field condition in the laboratory. So the one can able to find the real characteristics of soil through this test. And there are the three parts, that is UU, CU, and CD test of this, which we will going to discuss. The third one is the Valencia test, that is the test which performed on the soft and sensitive soil. It has application in the laboratory and the field setting as well, including the offshore environment, to measure the in situ shear strength in the difficult sampling situation. Okay, so after that, the torch shear test is that it overcome the limitation of the shear box test at the higher shearing and introduces a torch shear test as a as a method to apply the high magnitude of stress on the sample. It's significant in studying material behavior at the elevated shearing levels. The next one is the flat jack test. Use of the flat jack test in the rock mechanics for the foundation design. It has a relevance in assessing the stability and the strength of the rocky strata. Application of the flat jack test in the design of the hydroelectric power plant structures is one of the important factors. In penetration test, we perform SPT and SCPT test. These tests provide the information about the shear strength property of the material. Now we talk about the two tests in primarily, that is direct shear test and triaxial test. So direct shear test is a test in which the failure plane is already known, in which a small clearance is maintained between the two half of the box through which the failure is going to take place, and the box is usually square plane of 60 mm into 60 mm. This is a typical shear box is shown in in the following figure where over here we can see the shear force get up, normal load is applied and the roller is there and the failure plane section could be seen over here in the middle of the section where soil sample is retained and horizontal in a horizontal cross section we can see gap between that is the plane from which the failure takes place in this test. Okay, no problem. The condition which require for this test is the sample is fully or partially saturated, performed the porous stones depends upon whether it is saturated or not. If not, so the normal solid metal plates could also be used and a load normal to the plane of the shearing can be applied to the soil sample through the lead of the box. Over here, we know that tau is nothing but c plus sigma tan phi. So we talk about that where c is the cohesion intercept and phi is the angle with the horizontal axis. There is interrelation is also that is a sigma 1 equal to sigma 3 1 plus sin phi by 1 minus sin phi plus 2 c root of the sigma 1 plus sin phi by 1 minus sin phi. And okay, so this is the revision part which we are going through. Now we will take the new concepts from here and move ahead. Okay, so let me share this slide and share the another slide for you. Give me a minute. Okay, I think so. My slide is visible. Hello. Okay, it is visible. So we will move forward from here. Now we will talk about the. We will talk about. We will understand the shear strength in the diagrammatic manner, and we will go in the broader aspects of what we are talking about. Okay, I think so. I'm clear up to here. Okay, allow me to take some water. Okay, so now we are talking about the shear strength of the soil. So the soil shear strength is the ability of soil to resist the sliding along the plane or the shear surface. Over here, the load from the structure is transferred to the ground through the structural foundation. You can see from this picture the resistance which is offered and how the load get transferred is represented through this image, and one can see very easily that the shear strength of soil has been represented. Now we talk about some of the factors that affect the shear strength. So the first factor is the soil itself, because the different if the soil is the cohesive or the cohesion less, so its value get affected. The value of shear strength get affected in one way or the other. So the factors, one of the prime factor which affect the shear strength is the soil type. Different type of soil difference have the different property resulting in the different strength in those respective soil. As we can see that if water table is not there, so the same soil have different pH strength. If the water table is there, then the same soil represent the different strength. So the soil type is one of the most important factor. So when we do the soil classification, on the basis of that, we can understood this soil has this type of characteristics based on the basis of the Indian soil classification or any soil classification, we could understood the characteristics of soil, and on the basis of that we can comment on the strength which will be provided by that respective soil. The second one is the moisture content. The water can act as a lubricant and reduce the friction between the soil particle and lowering the shear strength. As it has been seen earlier, many a times we see that in soil the water is the most biggest problem. If water table is not there, the everything will be good and the construction takes place in a very simple manner. If the water table get rise at any aspects of time, its strength get affected. So it is very important and one of the most necessary things to take care of that whenever such situation arises, there is a very important thing that we will design for such condition as well, because it has been seen earlier when the water table condition doesn't consider the several structures gets damaged post construction. So moisture content is also one of the most important factors that affect the shear strength, and the example has been said by me at this point of time. When we talk about the effective stress, there is a total stress and effective stress. In the previous class, have explained briefly as well, so I will carry forward it. Over here, you see the stress is imposed by soil due to external load effects and the strength at which the soil particle interlock. So, when we talk about the effective stress to total stress and the pore water pressure. So you see, we say that sigma dash is equal to sigma dash, that is the effective stress, is equal to sigma, that is total stress minus pore water pressure. So by that manner we are able to find the effective stress. So when we consider the effective parameter, we also say C phi and C dash phi dash. So C dash phi dash is the effective shear strength parameter, while C phi is the total stress parameter. So in this fashion, we will move in a direction. When we talk about the temperature, so changing the temperature can affect the physical property of soil, resulting in the changes in the shear strength. And when we talk about the measurement and testing methods which is employed, so the measurement is the field wind test, that is in the field wind test, direct shear test and triaxial test, there will be some difference. So what is the difference? In the field wind test, a handled wind device is used to measure the the torque required to rotate the blade in situ, which can be used to calculate the soil shear strength. And in a triaxial test, a cylindrical soil sample. Okay. Okay. So in a field fancier test, a handle wind device is used to measure the torque required to rotate the blade in situ, which can be used to calculate the soil shear strength. Okay. And in a triaxial test, a cylindrical soil sample is subjected to the confining pressure while being compressed axially, and the resulting stress strain data is used to calculate the shear strength. Similarly, for the direct shear test, a simple sample is placed in a shear box subjected to constant normal force, and the shear stress required to be calculated at the failure is measured. And we have discussed these terms earlier as well at one point of time. So I think so these things will be never be a problem. Now we talk about the types of failures. That types of failure takes place in the soil. So first one is the general shearing, that the soil sliding along a plane or a shear surface. Second is the local shearing, localized soil slipping in the contact with the another soil layer. Third one is splitting, soil deforming and splitting into the inclined plane due to tensile stress. And the fourth one is the creep deformation, that is the slow deformation of soil due to the prolonged exposure of stress, typically resulting in the lateral movement. So one things need to be understood by one and all that when we talk about the general shear failure over there, the soil fell along the plane or the shear surface. But when we talk about the local shear failure, basically when we go ahead and we talk about these failures, you see some graphs how the general shear failures prolongs, like the load settlement curve. And when we talk about the local shear filling failure, over there we also discussed that how in the general shear failure bulging takes place at the top and how the local shear failure get dissipated over its length. Similarly, the splitting is a type of failure in which inclined deformation and splitting in an inclined plane due to the tensile stress. So this tensile stress doesn't get appear very often. So this type of failure is seen very less in one way or the other. But the creep deformation is a deformation which is not very significant in case of soil, but yeah, this takes place. Nevertheless, it takes place everywhere and in the most of the soil specifically. Not every soil, but it need to be understood when we talk about the application of shear strength analysis. So its application takes place in the slope stability analysis. How? That in slope stability analysis, it helps in determining the risk of the landslides by analyzing the soil shear strength and the forces acting on the slope. When we talk about the foundation designing, designing the safe and the stable foundation for the structure while evaluating the soil shear strength and stability, it helps with the foundation design. When we talk about the foundation design, it considers the all type of foundation, whether on the whether for any type of construction, where if we talk about the simple residential building, we talk about the multi-story building, we talk about the institutional structures, all type of structures require a design of foundation before its construction. So the foundation design is also one of the most important key aspects. Okay, moving ahead, we talk about the earthquake engineering. So in earthquake engineering, understand how the soil shear strength affect the behavior during the earthquake and designing the safe structure in the seismic area. So the in the earthquake design we need to understand the characteristics of soil. Basically, we know that if the seismic load had come, there may be liquefaction problems specifically in the soil is sandy. So it is very important we understand these aspects and work accordingly for the prevention of the damage due to the less value of shear strength. So the application of shear strength and how much strength it is giving is help in that direction as well. Okay, I think so. Up to here, everything is clear. Yes. Now we move ahead. Give me a minute again. Okay. Now we will move ahead with the introduction. That a finite element method FEM is a powerful tool in engineering research and advanced study. They enable the simulation of the complex real world scenario by breaking them down into the smaller elements. These elements interact with each other under the various conditions, providing the valuable insight into the material behavior and the system response. Constitutive laws are the fundamental in the FEM as they describe how the material respond to the external forces. In geotechnical engineering, the understanding the constitutive law is the crucial for accurate simulation and reliable predictions. Okay. Yes. Now we talk about when we say constitutive law. What do we mean by that? There need to be an understanding that whenever we talk about any words, any definitions, any terms, so what do we mean by that? This need to be understood. So what we understand from here? So you can see when we talk about the constitutive law of the material behavior. So constitutive law are the mathematical equations that relate the stress, okay, stress to strain and define how material respond to loading. The simple constitutive law often used is like tau equal to E into strain. That is tau is the stress, E is the strain, capital E is the elastic modulus of material. So this equation signify the stress is directly proportional to strain, reflecting the linear elastic behavior of the materials under the small deformations. In FEM simulation, these constitutive laws are the input into the computer program to replicate the real world material responses by analyzing the stress strain relationship. We gain insight into the how material behave and interact under the different loading conditions. Okay, I think so. Up to here, everything is clear. Yes. Okay, so wait for 2 minutes. Okay. Okay, I am talking about the constitutive law. Say there is a network issue over here. I am not able to find that whether I am audible or not. That's why I have to interrupt. Okay, no problem. We will move forward from here. So we are talking about the constitutive law of material. So the constitutive law of material behavior, when we talk about the constitutive law of mathematical equation that relate the stress and strain. We know from the very fundamental concept, from starting from the strength of material concept, that the strength is proportional to strain. When stress is proportional to strain, over there we say that stress is equal to E prime stress. That is nothing but E is a constant, that is the modulus of elasticity over there. Similarly, stress is proportional to strain multiplied by specific constant K is where K may be the modulus when we talk about in the shear condition, that will be the shear modulus. When we talk about in the direct normal condition, that will be the elastic modulus, and bulk modulus when we talk about the volumetric case. And the equation which signify the stress is directly proportional to strain, reflecting the linear elastic behavior of the material under the small deformations. And in the finite element simulation, these constitutive law are the input into the computer program to replicate the real world material responses. By analyzing the stress strain relationship, we gain insight into how material behave and interact under the different conditions. When we talk about the curvilinear behavior of stress strain graph, as we see that when a material experiences a large deformation or the higher stress, their behavior becomes more complex and the stress strain relationship deviates from the linear behavior, resulting in the curvilinear graphs. The concept of failure envelope emerges, re- emerges represented by tau is equal to A times sigma by B, where tau is the shear stress and sigma is the normal stress. And A, B are the material constants over here. Similarly, when we talk about the concept over where based on the when we talk about the constant where based on the analysis like the total stress or the effective stress analysis, understanding the shape of the parameter of the failure envelope help us to predict the failure and the deformation under the different stress scenarios. When we talk about the stress dependent strength parameter, so the shear strength parameter like cohesion and the angle of internal friction are the most crucial for assessing the soil behavior. Here, however, the C and phi are not fixed value. As we know, we couldn't say just by one test or one analysis that the cohesion of the this entire land mass of about say small plot area like 10 meters square or 20 meters square. If it is not in a very plain region, there is no unevenness, there might be substance that the C and phi will be found nearly, but if the soil parameters are not uniform, so the cohesion and friction angle is not same. Even the other soil parameters like the density, optimum moisture content, liquid limit, plastic limit, etc. sorry, are also not found to be same through the entire soil mass. So the stress dependent shear strength parameters are very important. So one need to understood like the C and phi value are the one of the most important parameter and they vary depend on the stress range in which the material is subjected. As the coefficient increases, the nature of the material response changes, its transformation from the frictional to the cohesive behavior. And when we talk about the dynamic nature of the C and phi, underscores the importance of the accurate parameter section in the geotechnical analysis. They vary based on the stress range in which the material is subjected, as the coefficient or say confinement increases, the nature of materials response changes and its transitions from the frictional to the cohesive behavior takes place. When we talk about the dynamic nature of the cohesion and angle of internal friction undergoes one of the most important for accurate parameter selection in the geotechnical analysis. When we say in the dynamic condition, we talk about the aspects specifically during the liquefaction as well. Because if a dynamic load is considered, there is a case of liquefaction may also get arises at this specific section. When we talk about the different stress range, call for the tailored parameter to ensure accurate prediction and safe designs. Moving ahead, when we talk about the transition from frictional to cohesive behavior, we say where the transition could take place from the frictional to cohesive behavior. But how? So the materials are subjected to increasing stress. Basically, stress are increased in a increasing manner from 1 to 2 to 3, 3 to 4, like in the step by step. So over there we can see that a fascinating transition behavior is experienced. Initially frictional in response, and the material gradually transforms into the cohesive material under the high confinement. And this transition from the friction dominated to the cohesive dominated behavior is vital aspect of the material mechanism. When we whenever we are going to say about material, we develop any material, or when we talk about the material. So when aspects gets changing over the period of times, our concern or our interest about those facts in knowing those things get increased. Similarly, so where the transition from the frictional dominated to the cohesive dominated behavior is achieved, so this is one of the vital aspects when we talk about the material aspects like material mechanics. So understanding this transition is a vital in the geotechnical design, where the stress level play a crucial role in determining the soil behavior, and the accurate parameter selection based on the stress condition is key to ensuring the foundation stability and overall project success. Okay, so over here we will take a small break, and after the break we will again come. Okay, so I think so. We'll take a small break over here. Okay, so we will see again in 5 minutes. Hello, 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 hello. 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 Okay. Am I audible? Yes. Oh, yes. There is a break over there, but it takes little longer, 2 minutes longer than usual because there is a network issue and some issue regarding the recording of this lecture. That's why it takes place. So sorry for the inconvenience, and there is also power issue over here from some time. That's also one of the major reason. But now I think so. Now class will go smoothly from here. So I will take 5-10 minutes extra maybe today to complete the today class because there are several obstructions in between. Okay, so I will move ahead. So in the last slide before the break, we are talking about the transition from the frictional to the cohesive behavior. So material subjected to increasing stress experiences a fascinating transition. We talked about this, that how it takes place. So I just did over here. Fascinating transition in the behavior initially frictional. In response, the material gradually transform into the cohesive material under the higher confinement. This transition from the frictional dominated to the cohesive dominated behavior is a vital aspect of the material mechanics. Understanding this transformation is vital in the geotechnical design where the stress level play a crucial role in determining the soil behavior. Accurate parameter selection based on the stress conditions is a key to ensuring the foundation stability and the overall project success. When we move ahead and talked about the stress range and the parameter selection. So selecting the appropriate shear strength parameters involves considering the stress range of the project. Different projects have the various stress regimes, and taking one of the example like for example embankment and foundation experiences the different stress level compared to the shallow slope or the retaining walls. Matching the parameter to the stress range ensures the really reliable analysis and the safety time. Geomechanics, the study of the soil behavior under the different conditions, guidelines, guided parameter selections. So this discipline allows the engineer to adapt to the changing behavior of the material under the varying stress scenario. Moving ahead with talking about the crushing and the particle behavior. So at a higher stress level, when the stress level is very high, the granular material undergo the particle crushing. Basically, when the stress get more the particle to particle interactions takes place, and the particle one particle crush on another, and the stress induced crushing of particle alter the material behavior and response. We say, suppose take a simple example. During the construction of road, the roller get passes one after other, one after other, one after other. So the particles are over there that get a stress layer over here. So its property gets changed a little bit. So under that factors, the behavior of material, the characteristics of material, like it's suppose talk about the simple optimum moisture content. How we when we find the optimum moisture content, we try to achieve it in the maximum tide density in the field up to that section. So that stress condition induce those property. So the behavior of material which we need to achieve. As earlier we also see that how the frictional behavior changes to cohesive behavior, that transport, that is also a type of transformation in the material behavior only. So this phenomenon occur in the specific zone on the stress strain curve, and the affect the material strength and stiffness. Understanding the implications of the particle crushing is crucial for the project involving load bearing structures. So, consideration of particle crushing zone is essential to prevent the structure failure and ensure the long term stability for the engineered system. When we talk about the material attributes and the geomechanics, the material behavior is influenced by the multitude of attributes including mineralogy, angularity, sphericity, density, and crushing strength, and the attributes collectively define how the material will respond to the stress and deformation. The complexity arises from the interactions of these attributes, though the material testing is necessary to assess the material behavior under specific stress conditions. The diversity of the material attributes require the engineers to tailor their analysis and the design approach to each unique project. When we talk about ahead in the material testing and application, so material testing is a crucial and as well as a critical step before utilizing the material for the engineer projects. Whenever we use anything, we need to test it whether it sufficiently fulfill the requirement which is needed. So the material testing is a critical step before utilizing the material in engineering projects. Just as athletes must understand their physical capacity, as we talk about athletes, there is a Olympic going on. We see that in every aspect, in every different fields, in different games, the different athletes require the different skill set to compete in that condition. So similarly, when we talk about in the field, just like athlete, as the athlete need to understand their physical capability, engineers also must need to be comprehend material behavior to ensure the optimal performance and as well as ensure safety up to the desired extent. Okay. When we talk about the analogy to the sport emphasizes the importance of the accurate material data for the successful project outcome. The proper testing and analysis minimizes the uncertainty, leading to the more reliable design and ultimately the success of the project. Okay, when we talk about the composite materials and some consideration which need to be taken in the coming days regarding the material. So, the geotechnical engineering, there is a growing interest in composite materials. By combining different materials, engineers can create the composite with the desired property. We see several research are also going on in the developing the material by mixing the different types of material, which may ultimately result in the increase in the strength in one way or the other. So that aspects need to be understood. And the composite material, so there, if you are using the composite material, there must be some advantage over the normal. So the composite material allow the innovative solution that can better address the challenges posed by the complex projects and the dynamic material behavior. The future of geotechnical engineering involves pushing the boundaries of the material science to develop the innovative solutions that improve the sustainability, safety, and efficiency of the construction and the infrastructure project as well. Okay, I think so. Up to here, there will be no problem. And when we go ahead, we understand the constitutive law, material behavior, and the parameter selection, essential for the accurate geotechnical engineering analysis and design, and the dynamic response of material to the stress ranges underscores the need for the tailored approach to the different projects. Okay, now we talk about when we concluding these aspects, we understood that the how whatever we read, like the constitutive law, material behavior, parameter selection, everything is most important and need to be in the accurate manner for the geotechnical analysis and design. When we consider the earthquake aspect, the dynamic aspect, the response of material to the stress ranges underscore the need of the tailored approach and the different projects by recognizing the diverse attributes that shapes the material behavior. Engineers can make the informed decision that ensures the project success. The interdisciplinary nature of the geotechnical engineering challenges is in the material science, mathematics, and the practical applications creates the robust, resilient infrastructure. Thing need to be remembered to supplement these explanation with the relevant aspects. Okay. Now we move to the soil mechanics fundamentals and triaxial testing. So over here, what we are going to cover. This need to be understood by us that what we are talking about when we say the soil mechanics fundamentals and the triaxial testing. So we will moving in this direction. So we will see what we are going to see over here. Okay. Oh, sorry. By mistake, I have stopped presenting. Okay, give me a minute. The problem. Sorry, there is a problem over here. I couldn't able to find my mouse. So give me a minute. I will be there. Okay. So the network is over here. So I couldn't able to share at this point of time. Let me try once more. Okay. Are you visible? Okay. I think so. My slide is visible. I think so. Yes. So we are talking about the soil mechanics, fundamentals, and triaxial testing. So, first of all, starting with the introduction. So, in introduction, in the field of the geotechnical engineering, understanding the behavior of soil under the various conditions is crucial. Okay, I think so. Now the slides are visible more accurately. I feel there is a problem that slides are not moving at some point of time, so I will go with this at this time. Okay, so we are talking about in the field of geotechnical engineering, understanding the behavior of soil under the various stress conditions is crucial for designing the stable structure and foundation. As the shear strength is one of the most fundamental parameters that play a pivotal role in determining the soil stability. So, in this presentation, the focus on selecting the shear strength parameter, its concepts that underlie the significance of the triaxial testing characterization of soil behavior is we are going to discuss. Okay, so in this we are talking about the shear, we are talking about we are talking about the shear strength and the shear strength and the stress strength behavior. So starting with the initial behavior, whenever we are talking about the behavior, so we need to understand that we talk about first of all the behavior which it shows at its initiation. So in initial behavior, imagine a spherical particle under the compression initially its tolerance stress within the elastic range as when we reach to the second stage, the breakage and crushing takes place. So whenever a specific as we consider a spherical particle, suppose that spherical particle be like this. This is a no, this is not a solid. Okay, let me show you. Suppose this is a spherical particle. Okay, so when it's go under the compression, there is a compressive force applied. Suppose it is applied from up and down or all round direction, whatever you think. A spherical particle and the stress is applied on it, so it tolerate a stress when within the elastic range. After that it get filled. So whenever we see the stress strain graph, there is a section up to which it go in the linear manner, and after which the non-linear case starts. Basically, elastic range get over, and up to the plastic range, whatever the plastic range is there, up to that it will go, and then the fracture takes place. You must have understood this for the mild state. You have seen the mild strain graph. Similarly, the stress is applied, it will go up to a certain limit, and after given that it will get filled. So at the breakage and crushing beyond a point, breakage and crushing can occur, leading to the changes in the particle shape and sphericity. And why as particle shape gets changed? Because when the crushing takes place, when the crushing takes place over this spherical particle, it get crushed. It's the particle orientation. Suppose imagine a big stone. Imagine a big stone in the spherical shape. When a stress is applied, it will get break, and when it will get a break, it modifies it and it get sustain in a small location. So the breakage and crushing takes place. After that, what takes place? Interlocking effect. A particle become irregular and flaky. First of all, our particle is spherical, but when it gets break, particle became irregular in shape, maybe the flaky in shape, and a flaky the interlocking effect emerges, affecting the compaction. With now the interlocking takes place. As we see, you consider a small spherical cell which is made up of glass, maybe. So when you fill it in a specific container, you see there are too much space left out. but the same thing when crushed out and then filled it over there, it retain the less volume as compared to the whatever the spherical balls which are made of glass are especially placed over here, earlier placed over there. So this understanding need to be developed. So what we are talking about after that, the cohesion and interlocking. As the increased irregularity enhances the interlocking, leading to the more cohesion and cohesive soil behavior. As we say, as we know from the very start of the class, from the first class, we know that the due to intermolecular force, the cohesion force are there, and which is one of the most important aspects of considering or in accumulating the shear strength of the soil. So up to this, I think so things will be clear. Now we will move ahead when we talk about the density and shear strength. We will say, sorry. Okay. So when we move ahead, we will talk about the density and the shear strength. So the dependency on density is also there as the shear strength graph are the density dependent. Basically, density is why one of the important factor, because when we calculate sigma, the we talk about the stress, we talk about the effective stress. We have talked earlier as well. So effective stress is calculated based on the basis of the density. So the density is one of the important factor, and when we talk the comparator like the cohesion versus friction, so shear strength increases due to cohesion but not friction. Because as we know, if we consider the direct interrelation as S equal to C plus equal to 5, when we talk about the cohesive soil, as the cohesion get increases, the shear strength get increases directly without a doubt. But when we talk about the friction, those aspects depends whether the what is the phi value and how it will vary from one place to other as we get our understanding get depth. Okay. Similarly, when we talk about the two component strength, the shear strength arises from the interplay between the cohesion and the friction. When we talk about the behavior of soil, which vary differently when we talk about the sand and clay, the general soil exhibit varying behavior under stress. When we talk about cohesion and friction, so not limited to specific type, that is the sand only showing friction or clay only showing cohesion. So this is not a limitation. There is no aspect that one can say this is only the clay soil, it has only the cohesive characteristics, and another is the sandy soil that show only the friction characteristics. There may be the certain cases at different point of time where the C5 behavior both present. So this understanding need to be there. Okay. When we talk about the triaxial testing and the stress tests, so when we talk about first of all the direct shear testing, you for the soil response characterization, and when we talk about the triaxial testing, interpolates the state of stress with the soil exposed. As we have said earlier, in the triaxial test, the real field condition gets simulated in the laboratory as in the field as well. The stress is acting for the all the horizontal direction, which is confined by applying in the confining pressure as sigma 3 on the soil part, and after applying a vertical stress from the top, that is the deviatric stress, so that interpolates the state of stress to which the soil is exposed. And when we talk about the third factor, that is the stress conversion, so changing of the stress states affects cohesion and the angle of internal friction. When we talk about the texture, friction and cohesion, so when we talk about the fine grained material, the texture governed by the pore structures and the structures influence cohesion. And when we talk about the cohesive grained material, the particle property like the shape, size, and the specific gravity determine the behavior. And how it will take place? How? When we talk about the cohesive grain material, so the as we have discussed the particle behavior, particle shape size are also equally important because that will result in the intermolecular force of attraction, which is responsible for the strength in the cohesive soil and whatever we are talking about. So that is also one of the most important factor in the grain material. Okay. When we talk about the time dependent deformation, so the deformation takes place, two types of deformation takes place, like consolidation settlement takes immediately. Why? Because there are two types of settlement. One is just basically due to some airs voids are placed in the field. So it will, when a hammer get placed over there, it will exit out and that consolidation takes place at start. Second is the consolidation settlement. Over there, the waters filled in the voids get removed in a increasingly manner, and its factor also depend differently on the different type of soil. So when we say it depends differently on the different type of soil, then the question arises how? What are the aspects we are talking about? How it behave differently for the different type of soil? Yeah, this is the correct question. So suppose we differentiate like the sandy soil and the clay soil. So in the sand, water get dissipated very quickly, as we have discussed earlier as well during the triaxial test. It present the confinement. It present allow the water to flow out. Basically, the in the sandy soil, the pores are sufficiently to move out the waters. So the in sand, the water flow out very quickly. So we can say that the consolidation settlement takes place during the construction work only. But when we say the soil is not sandy soil but the clay soil, so over there the very small pores are there. The pores are large in number, but the pores are very small, and the water flow out from those pores takes place very large amount of time. So that's why when we say the allowable settlement in the clay, it is said to be less because over there the settlement takes place in a large amount of time as compared to sand. So that is also one of the most important aspects when we talk about the tip, like the long term deformation due to the constant stress, especially in the fine grained soil. So in the fine grained soil, the when the load is applied and we see that the load is there from the large part of time, so in increasingly order the stress get increased and there may be some deformation takes place over there. So that is another type of time dependent deformation, which is said to be creep. Okay, I think so. Up to here, everything is clear. Okay, okay. So we'll move ahead. We talk about the triaxial testing, and we see the plane strain versus three. We see triaxial testing, plane strain versus three dimensional. That how the plane strain and how the three dimensional testing we see now. We have interrelated sigma one and sigma three during the previous session. In the last week, I have shown you. Give me a minute. Let me load to full screen it. Okay. Yes. So, as you remember, during the last class, I have seen the triaxial apparatus presentation. Over there, you can see that we have interrelate like sigma 1 and sigma 3. For your information, I will again say some point about that. We say that the confining stage and the diabatic stage. So, during the confining stage, the sigma 3 is acting, which is acting all around from the all direction, and that will be act with the help of the water field over there. Okay, but when we relate the terms, we say that the sigma 1 is there, sigma 3 is there. We interrelate those terms in the term of C and phi is sigma 1 equal to sigma 3 times 445 plus 5 by 2 plus 2C tan 45 plus 5 by 2. Okay, so I think so. So over there, you understood the value of sigma 3, that is the confining stage. The stress is acting all around, and after that, a deviating stress is applied from the in the normal direction from upward. That is nothing but the sigma 1 minus sigma 3. And when the value of deviating stress is known, after that sigma 1 and sigma 3 known, and we know that specific condition. We talk about the three conditions like the UU test, CU test, and CT test, and we understood in the different condition when we consider C as 0, 5, and 0 depending on the requirement when we are solving, and the other information are not known to us. So how we are able to know those parameters which could be helped, which could be used during the finding the shear strength of the soil. So I think so that things is clear. Just a term came here, so that's why I take some time to revise those terms over here. Okay. So we are talking about the triaxial testing, that is the plane strain or the three dimension. So when the plane strain perpendicular to the system are negligible, but when we talk about the three dimensional case, more realistic but the complex and the expensive, um, it's declared in the lab, as you know, no, in the like suppose that there are different type of tests. We see mostly when you go across, if you are the professional engineers, so you can see that in the soil report you never see that the triaxial test performed very often, because it is a time consuming as well as some sophisticated or the expertise people need to be there to perform those tests. Basically, when I discussed the triaxial test, we came across the A and B, that is the Scampton parameter. Over there, the B, the delta U by delta sigma 3. Similarly, A bar equal to A into B, and A bar equal to delta U by delta sigma 1 minus delta sigma 3. I think so. You have remember. If not remember, you can go across the previous lecture presentation as well. Over there also that is mentioned. So the parameter B need to be one, because if we need the soil is in the fully saturated condition or not, so that need to be developed. So those things are there. Okay, what I am talking about, why get debated over there. I also forgot. Okay, no problem. I will move ahead, and if any term is required, I will go over there. Okay. So we are talking about now we will talk about the volumetric deformation. So how the volumetric deformation takes place? First of all, when we talk about the triaxial loading, in the triaxial loading, the stress is when we talk about the strain, like the volumetric strain, that is the volumetric strain in the x, y, and z direction. It is the sum of the volumetric strain in the x, y, and z direction. In the when we talk about the triaxial loading, if we, similarly we consider the volumetric deformation under the consolidation loading, so the undimensional loading assumes uh, strain in the two direction, that is x and z. Whatever you assume, y, if you are assuming the third direction x and z to be same, and the third direction is assumed to be negligible in the consolidation state, because over there the consolidation practice we are performing. Okay. Now we talk about the Poisson ratio coefficient. Give me a minute. Hello. Okay. Sorry. I think so I'm not audible. That's why I need to check in some time by myself. Okay. So now we talk about the Poisson ratio. So first of all, see the plane strain versus triaxial. In the plane strain has the higher Poisson ratio due to the less confinement, as we know. In the triaxial, the confinement is more. Ah, because in the triaxial, first of all, the soil sample is made. It need to be stand over there. So a membrane is there in which it is kept out. After that, the diabetic stress is confining pressure is applied. After that, whatever the condition we are performing, we need to open the valve or close the valve in order to water to flow out. So that condition are there. That's why the Poisson ratio is little bit less over there as compared to the plane strain case. Similarly, when we talk about the confinement effect, so the confinement effect in the laboratory for the realistic parameter determination, because as I have discussed this point at the different point at different time, that the deviatric that the in the real field situation, as we suppose any field condition, the soil is there, Suppose wherever you are at this point of time, if you go to field, you see soil is there. Assume a soil below 1 meter below your feet. The soil is there. If you consider a soil cylindrical sample from there, so the stress acting from the all the horizontal direction over there in same in a manner with the help of the adjacent soil as well. So that condition need to be maintained in the laboratory in order to found the real situation. So in the triaxial test, that confinement effect need to be achieved. Yes. Okay. So that we need, that we are trying to achieve. Now we talk about the significance of the triaxial testing. There must be some significance of the testing which we are performing over there. If the direct shear test is already there, then shear test is also there, which we are going to discuss as well in the coming slides in this class only. So, a direct shear is already there. We know that it is relatively easier. We also know that there are some limitations which we have discussed. So, oh, is there any additional significance of the triaxial test? We also know that, but it is really little bit time taking and but also represent the real behavior as the pore water or it could also be controlled, could also be measured. So that's are the some different significance over the other tests which are over there. Okay, so we talk about first of all the cylindrical sample. A cylindrical sample in the triaxial testing uses the cylindrical sample of the symmetry and accuracy. As I have discussed at the just now, I have discussed this point already that we consider the any soil sample below the ground which in cylindrical in manner. So that type of composition we made in laboratory on those soil, so that signify the real field condition. Okay, when we talk about the testing, as if it takes place on soil or concrete, so the geotechnical engineers focus on the intermediate behavior, unlike the concrete testing. So some of the findings, some of the conclusion we can say from these sections which we could get is that we understand the shear strength and the soil behavior under the different stress condition is the essential for the safe and effective construction project. The triaxial testing provide insight into the complex interaction between the cohesion, friction, and the stress states leading to the better designed foundation and the structure. Now we will move to our next test, that is the behavior testing and the behavior of the sensitive soil. As you know, we have when we are taking the brief definition of all the tests like the box shear test, that is the right shear test or triaxial test or the brain shear test or the different tests. We come to know that the Bhil shear test is performed in the soft soil normally. So over there, I also discussed that some aspect like when we perform the Bhil shear test, it need to be rotated, some torque need to be applied. If soil is not soft or sensitive, the rotation doesn't take place. So the interrelation which we know T equal to tau equal to T by pi d square into h by 2 plus d by 6. If our brain shear apparatus is completely inserted inside the soil, so that interrelation could not be accessed as no torque could be applied, so no result could be achieved. Yes, I think so. Yes. Okay. Okay. Okay, so we will move ahead on the behavior testing and the behavior of sensitive soil. So when we talk about the behavior test, it is a test. Behavior shear test is a valuable method for accessing the shear strength of the sensitive soil, striking a balance between the two-dimensional and three-dimensional technique. As you know, we have talked about the direct shear test, we talk about the triaxial test. In the triaxial test, exact three-dimensional aspect is achieved, but that is not with the case of the direct shear test. So it is the in between those two aspect, like in 2D and 3D. In this, the presentation, we will see the mechanics of the vein shear testing, its application, and the insight it offer into the cohesive soil behavior. Okay, now understand the vein shear testing, how it will take place, and afterwards we will go across the procedure which is used during the testing. Okay, so first of all, in the vein shear test, it is a method to measure the shear strength in the sensitive soil. When we talk about it is a provide a balance between the 2D and 3D, we talk about it is a middle ground between the plane strength and the triaxial testing. And there is a mechanism applied, that is said to be vein mechanism, in which rotating a vein with the soil in a soil sample to mobilize the shear strength. Over here, the interrelation also is used to find the sensitivity in the soil. When we talk about the setup which need to be there, is the first of all the caging or a sampler is needed, which is caging or sampler is needed, which is used to contain the soft and sensitive samples during the testing. And at second, the wind rotation is applied. First of all, what happened? Caging or sampler is there, which will be inserted in the soil. After that, a rotation is applied. So, the lowering the vein into the sample and applying the torque for rotation. After that, the testing up is adapted for both the controlled in the lab condition as well as the offshore environment. So I will suggest you one more thing, as I have earlier suggested for the previous direct scale and triaxial test. Over here also, you if you are in the college going students, go across your laboratory and try to perform the Valencia test as well. If the laboratory setup will must be there. There is simple soil sample you need to make, and afterwards the rotation need to be applied, and you will able to find the Valencia test performance. If you are if those equipments are not accessible, you may be a working professional. There is a PowerPoint. There is a practical presentation is also shown by NCTEL. NPTEL teams arbitrary we show the laboratory test. So you can see the demonstration as well, that will also help you in the better understanding of the actual equipment and actual working. Okay, so after that, laboratory and field testing is performed, and when we see that how the cohesion mobilization takes place over here. So the some configuration need to be understand. That is, first of all, the main blade will must be there. So that blade must have a specific radius, that is arm. The length should be there. That is the length of the blade, that is L or H, whatever you want to represent. After that, the torque application is that, as you know, I have said the interrelation to find the shear strength as T by pi d square into H by 2 plus T by 6. So over there, T is the torque which is applied to rotate the vane shear apparatus, and D is the dia of that blade, and H or L, whatever you say, T by pi d square to H by 2 plus D by 6. So H is the height of that blade, length of that blade, you can say, and in that manner we can able to find the value. So the cohesion mobilized vertically as well as horizontally when we are see perform this test. When we are talking about the cohesion get mobilized, so there must be some fashion. So when we talk about in the vertical plane, so cohesion mobilized vertically due to the vane rotation, while in the horizontal direction it distributed for the soft and sensitive soil. While when we talk, if the vane is implanted in the soil layer, there must be the end bearing analogy, and that analogy say that the end in the bearing in the structural pies. Okay, so that point is not important. So left. Now we talk about the Bayes year test, how we solve. So you see this slide. In this slide, Okay. Okay, so we talk about the solving the Venn test. So you can see that first of all torque calculation is performed. So in the torque calculation, first of all, torque need to be required to be the shear strength need to be found. After that, the CV calculation takes place. That is the expression for CV mobilization in the vertical and the horizontal plane. After that, the annulus ring is implemented contribution of the annulus ring to the movement. After that, the known and equations are used to solve the problem to find the solution. So you can see in a Bayes test, when we perform the Bayes test, there must be some importance, some of the scope, and what are the requirement to perform this test. So when we see this test, so it is a cheaper and quicker method, and this test can be conducted in the laboratory. As I say earlier, this is the field as well as the laboratory test, and the structural strength of the soil is basically a problem of the shear strength test. So the vein shear test is useful method for measuring the shear strength of clay. As I say, the clay get mobilized. Okay, so by applying the torque, we are able to mobilize that in the horizontal as well as in the vertical direction. And as I have said, in the horizontal direction distribution for the soft and sensitive soil, and in the vertical direction due to the hand rotation. Okay. When we say as I have said earlier that it is a cheaper and a quicker method, so test can be conducted in the laboratory, and the laboratory vein shear test for the measurement of the shear strength of the cohesive soil is useful for the soil of the low shear strength, that is less than 0.3 kg per cm square, for which the triaxial or the unconfined test cannot be performed. Okay, no problem. And as we, sorry, there is problem. Okay, so this test gives the undrained strength of soil, and the undisturbed and demolded sample is strength is obtained, that is used in evaluating the sensitivity. As we know, the sensitivity, the undrained shear strength, undisturbed by disturbed sample on undisturbed by demolded sample. So with the help of that interrelation, the sensitivity could also able to calculate by the experiment. Now we say what are the equipment that are required for the calculation of shear strength in the vein shear test. So first of all, if the vein shear apparatus is required, after that the specimen, the soil sample in which the vein need to be implemented for providing a rotation, and then the specimen container, the container in which the specimen will be there if it is not performed in the field, and the calipers are also needed. Okay. Okay, so the how what is the procedure? So first of all, prepare a 2 or 3 specimen of soil sample of dimension 37.5 mm dia and the 75 mm length in the specified L by D ratio, that is 2 to 3. Now mount the specimen container with the specimen on the base of the main shear apparatus. If the specimen container is closed at one end, it should be provided with a hole of about 1 mm dia at the bottom. Now, gently lower the shear vein into the specimen to their full length without disturbing the soil sample. The top of the vein should be at least 10 mm below the specimen. Now, note the reading of the angle of twist. As okay, there is a power shutdown over here. So we okay. Now rotate the bean at the uniform rate of 0.1% by the suitable operating the torque application handle until the specimen fail. Now note the final reading of the angle of twist. Find the values of the blade height in cm and find the values of blade width in cm. The height is said to be h and the width is said to be dia, which we use in our interrelation. Now the calculation is given as T by pi d square into h by 2 plus d by 6. Over here, the shear strength is found, that is S, and T is the torque in the cm, kg cm, and D is the overall diameter then in cm, which we calculated as the width, and the T is the spring constant, that is 180 into difference in degree, as we have measured in our step the final reading of the twist, the second point over here, and first of all the initial reading in the last point in the last section. Okay, so with the help of this interrelation, we are able to find the shear strength of the soil, and in the same way, we are able to find the factor of safety as the working value as the peak value divided by factor of safety. Okay, I think so. Okay, now we talk about the advantage of VNCR test. There must be some advantage, that's why we are using. Otherwise, the earlier we have another test already with us. Why we are doing the VNCR test? So in the VNCR test, the dual equation is obtained by repeating the test, providing the CV value, and in the heterogeneous soil, the handling layer soil scenario with the multiple equation, as well as when we talk about the sensitive soil analysis, the valuable for the soft and sensitive and the quick clays. When we talk about the sensitive parameters, so sensitive parameter as we say the ratio of the undisturbed shear strength to the remolded shear strength as a definition of the sensitivity. And when we talk about the classification scheme, so it describes the soil sensitivity based on the S and the S values, and the quick clay associated with the marine environment and the environment for the offshore region is also could be implemented. When we talk about the importance for the infrastructure development over there when we perform the Benzier test, so in the offshore development increase the focus on the offshore region for the infrastructure. Some challenges like the engineering solutions of the soft soil in the marine environment is one of the challenge, and the engineering uh, soft clay is a starting point for understanding and managing the sensitive soils. When we conclude this section with the fact that the Wales here test bridges a gap between the 2D and 3D soil testing techniques, making it valuable tool for the accessing the shear strength of the sensitive soil. Now the main shear testing engineers gain the insight into the cohesive mobilization pattern into the both vertical and horizontal plane, enabling the more informed decision in the infrastructure development, especially in the challenging environment like the offshore region. After that, we now move to the next factor, that is the settlement. So in settlement, we know as QB into 1 minus mu square by E into IB, where IB is the influence factor, mu is the Poisson ratio, and Q is the load per unit area, and B is the width of the foundation. So with this interrelation, we can able to find the settlement, that is said to be the elastic settlement. Okay, give me a minute. Okay, now you can see we talk about some of the challenges in determining the shear strength. So some of the main challenges are the soil variability. Soil composition, structure, and condition can vary significantly even with a small area, making it difficult to determine the shear strength accurately, as I have discussed earlier as well. If we are going to calculate the shear strength in the small region, we consider small area, there must be the some test sample need to be taken before accessing, before the stating that this much the value of the shear strength parameter and this much value of the shear strength. There is only test could not confine the result for the entire region. Similarly, when we talk about the other factors like the soil saturation level, the time under the stress, degree of compaction, etc., also impact the soil strength, impacting the analysis. The next one is the accuracy of the instrument. As the accuracy of instrument used to measure the shear strength can significantly leading to the error in the analysis. And it is also found that the instrument error is also over there at some point of time. So that need to be accessed. The one of the most important aspects about the instrument, because the but in the soil mechanics we see that a little bit value of difference will not significantly affect the result. So that not a major problem, but the major accuracy problem in the instrument could lead to with the wrong information regarding the result which is stated over there. So that need to be taken care of. Okay. Now we talk about the current and the future research in the shear strength analysis. So the some of the smart sensors like the advancement in the sensor technology allow for the more accurate and continuous monitoring of the soil condition, providing a new data for the analysis and improving the safety in the various applications. There is machine learning. Using the machine learning algorithm can help interpret and sorry, interpret and integrate the large quantity of data from the various sources to improve the accuracy of the soil strength. The third one could be the bio-inspired solutions. The some of the researchers are working on creating the new ways to improve the soil stability by drawing the inspiration from how the material and structure nature perform. Okay, with this we will end the today's session. But before ending the today's session, I will leave you with some questions. So, what are those questions which you need to answer? Oh, and one more thing. In this lecture, I haven't taken questions because in the last two lecture I have taken some of the questions. But in this lecture, the some questions are get missed out because the topic is not consisting of that much problems. That's why. So in the subsequent class, I am going to take the mini problems. So be prepared with that. And as I have stated in the previous two lectures as well in my presentation, also the question that guide your reading always there over there. I have given some problems, so you will solve those problems as well before coming to next class. Over here, some question I will ask again that what is the shear strength? Write a detailed procedure of the direct shear test. The similarly write the detailed procedure of the Bayes shear test, and one more aspect that if these two tests you could able to perform in the laboratory or at your institute or at any place, try to perform it so you able to understand it more practically. And over here the triaxial test is not mentioned, but try to write it. And one of my suggestion again at the end that you can go across the demonstration of this test as well in the some of the videos which may be present on the YouTube. That will also help you to give better understanding if the those equipments are not accessible to you at this point of time. Now another question is that effect of cohesion and friction angle on the shear strength, right? That what are the effects? And the elastic settlement, that is QB into 1 minus mu square into IB by E, that is the elastic settlement. What is the Q, what is the B, what is the mu, you need to understand. And some problems you can also solve on that. That not necessary, but if you could, that will be very good. So with this, I think so I will end the today's session. These are the some of the reference books which you can refer to solve the problems, from which I also try to deliver the content which is here. So with this, I will end the today's session. Wish you a very happy weekend. Thank you very much for joining. I will see you in the next class on the next Saturday at 3 p.m. So be there. And one additional point I want to add on for those who are attending in the YouTube classes, and that if any problem is there, any confusion is there, you can come to class. I will try to answer those queries in the next class. And this class end up over here. See you in the next class. Thank you very much.